Our next topic would be the natural circular frequency, which is denoted by omega sub n. So first, what is frequency? Frequency, which is usually denoted by F, would be equal to the number of cycles per unit of time. Usually we call this cycle per second, or its unit could be hertz or 1/second. In relation with this, we have the period t, which is the time it takes under number of cycles. Or basically, this is second over cycle, which is, as you can see, it is the reciprocal of f, or the frequency. There you go. Usually denoted by the unit second. Now, as I have said, we will be talking about the angular frequency, which is again is denoted by the omega, which is a rotational analog, and it is usually denoted by the amount of angle transverse, per unit of time. And since uh, we could express this with radians over second, radians could be, you can say that radians is unitless. So a good way to think of this angular frequency as the omega is equal to radians per cycle multiplied by the cycle per second. So we could cancel out cycle, then we have radians per second. We could see this on a graphical representation. Let's say a circle. Okay, which we have 360 degrees or 2 pi rad. 2 pi rad, okay? Let's define radians first. Radians, it is equal to the arc length times its radius. That is what we call radians. It is a dimensionless unit. Again, it is the ratio of arc length to its radius. So arc length and radius, you can see it could be denoted by a unit of length, which is, for example, meters, and the radius also in meters. Then we could cancel it out. Radians is basically unitless. Okay. Let's see on another page. You usually have seen you we usually work on harmonic equations like what we used earlier. For example, um, C1 cosine k over m times t plus C2 k over m, I mean sine k over m times t, or the time, or this t is denoted by some time after we exerted an acceleration. So this this variable here, this is the frequency of our equation. So K being the spring stiffness or spring variable, and M as its mass, we could see that the units of K would be Newton per meter or kilogram per second squared. And then we have here the mass, which is denoted by kilogram. Could cancel out kilogram, so we only have the square root of 1 over s squared, and therefore we have omega as 1 over s, which is the same unit as the frequency, which is hertz.